Okay, today we're going to take a look at integration by parts, which is based on the product rule of derivatives for derivatives. So if we take a couple of functions and we take their derivatives, so let me just put that in. From earlier, we recognize that we get f of x times g prime of x plus f prime of x g of x. And now let's integrate both sides. So we'll get the derivative being integrated, and then we'll integrate each of these. With respect to x, what ends up happening is we see that the multiplication of those two functions will now become something that we can rearrange a little so that we solve this for the integral of f of x g prime of x dt. This one, we'll just solve for the middle term. And so you get the integral of f of x g prime of x dx is equal to the two functions multiplied together, take away the integral of f prime of x gx dx. And often this is rewritten in terms of u and v rather than in terms of f of x and g of x. So let me just show you that with this substitution. We now get u times v prime is equal to uv minus the integral of vu prime. And you can check that that is true. And really, this is u with the derivative of v is equal to uv minus the integral of v du. Let's see how this works with an example. Let's try taking the integral of x e to the x dx. And what you'll notice is that this has the form where there are two functions essentially multiplied by each other. So what we'll do is we'll choose our u to be one of those functions, and our dv to be the other function. So we'll make dv the other function. And this one we integrate, so we know that du is dx. But this one, this one we take the derivative of both sides, but this one we integrate. And when we integrate this, we get the integral of e to the x dx, which is just e to the x. And so we can take this original, we can think about this piece being u, and as I said, this piece being dv, and according to the function, according to this equation that we have at the top, if I have u and dv, I can rewrite this as u times v. So now I use this information to fill in my row. So u times v, and then I take away the integral of v times u prime, which is du. And in this case, du is dx. And I can solve this by saying it's now x e to the x take away the integral of e to the x is still e to the x plus the constant value. Let's take a look at another one of these. And again, we really want to focus on thinking about the form and how we can take our example and match it to that form. So in this case, we'll take the integral of x sine x dx. We can match up this piece with u, take its derivative, and we can match up this piece with v prime, or dv, and we can take the integral of each side of these to find our v, and so I get negative cosine x. And then I can use this form, so I can say, well, this is equal to the u value, which is x, times the v value, which is negative cosine of x, minus the integral of the v, which is minus cosine of x, and then the derivative of u, which is dx. And I can do some quick simplifications to this to get the final answer, plus c. So some tips on doing this. First of all, dx always has to be part of the dv. Second of all, this dv that you choose should be fairly easy to integrate, but the du, even more importantly, needs to be easy to integrate. And u and du are chosen so that the integral of v du is way easier than the integral of u dv. So because we have options, you could have chosen in this case this piece to be v and the other piece to be u. So look one step ahead, as it were, to see which one is a little bit easier. I'll leave you with two more examples. So in this case, I'll choose my u to be x squared and my dv to be e to the x dx. So du is 2x dx, and the integral here, v, will be e to the x. And so I can find, using the equation I gave you earlier, that this is the same as x squared e to the x minus 2, and then x e to the x dx. Now, unfortunately, this second piece, this integral that's left, does not simplify very easily because it is, again, a product of two terms. So what we do to solve this kind of problem is do parts again. So think about this question as though it were the question that I actually started with. I gave you the answer to the integral of x e to the x earlier in this video. And so this becomes e to the x. You do another substitution with this piece. You can check earlier in the video that this simplifies to x e to the x minus e to the x plus c. And we can simplify this if needed. And our final example, let's just take a look and see what happens if this is a definite integral. So like I did before, I choose my u value to be x and integrate it. I choose my dv value to be the other part, in this case secant x squared dx, and integrating both sides gives me tan x. And this allows me to use the equation from earlier to get u v prime, sorry, u times v integrated at pi over 4 minus 0 minus the integral from the same pi over 4 0 to pi over 4 of tan x dx. So this piece, when you put in pi over 4, becomes pi over 4 times 1 minus 0 minus the integral of tan is ln absolute value of secant x evaluated at pi over 4 to 0. Substituting this in gives you pi over 4 minus, substituting in pi over 4 here, secant of pi over 4 becomes square root of 2, so this becomes, and then substituting in 0, secant of 0, ln of that becomes 0, and so there is my final solution.